hopefully this is in frame after I move it. So this is our plate number 2. We have a 3A PE panel, 0.20 inches thick, and then we have this glued using T88 resin to a Kevlar panel, 14 ounce K29 Kevlar panel that is also 0.20 inches thick. So the total thickness is 0.40 or around half an inch. It'll probably be a little bit over half an inch once we're done with the entire thing. I'm not exactly sure what it's rated. I would assume it's 3A. It is 14 layers of K29 Kevlar, and I think that definitely is it's at least 2A. I would assume it could also handle 44 Magnum. So we're just gonna go with, it's a 3A Kevlar panel. I'm not sure what type of resin was used to make this panel, but I definitely know this is K29 Kevlar. And I'm not exactly sure on the layer count, but I'm pretty sure it's 14. So yeah, I just sanded this down with some 80 grit sandpaper on both sides to help it bond together. And currently I'm just gonna do like a Kevlar like attachment system just to hopefully keep these from separating. Just gonna use some super glue originally, and then when we do the final layup, this obviously will get saturated with resin. So currently I'm just gonna use some super glue to hold it down in place. So theoretically 2 3A panels, 1 PE, 1 Kevlar. I'm going to add 12 layers of 6 ounce carbon fiber to the front like that, and then backing the PE will be 2 layers of carbon fiber and 2 layers of Kevlar. It's gonna sort of kind of go like this, and then they're gonna fold over. So I'm gonna do that right now. Okay, good enough. Alright, so here are our 2 plates. This is the carbon fiber 14 ounce K29 Kevlar, and then the 3A PE backer plate. We have 12 layers of carbon fiber up front, and then there's a trauma reducer, 2 layers of carbon and 2 layers of Kevlar at the back. I'm gonna see if these stay together. As you can see, I did this sort of Kevlar strap attachment system, one on each side. Hopefully it keeps these 2 separate panels from separating. I mean, it probably won't even have a chance to separate because I don't think it's gonna stop anything, but I guess we'll find out. If it does, I'll be thoroughly impressed and very surprised, because this only weighs 10 ounces, super light. Obviously you have this chunk missing out here, but that's probably only like 2 more ounces for a almost 6 by 5. So 4 of these, plus the shooter skull, a little bit less. It's probably like 3.5 pounds, and it's only 0.55 inches thick. So if it does stop, just 5.56 ball ammo, that would be amazing. There's no way it's gonna stop M855. I probably won't even have to shoot it with this, just because I don't even think it's gonna stop this to begin with. This is our second plate. We have 54-ounce fiberglass up front, 6 layers. And then we have 9 layers of carbon behind that, 14 layers of 5.5-ounce Kevlar behind the carbon, and then a 3A PE plate, and then 4 layers of carbon at the back as a trauma reducer. As you can see here, the 54-ounce didn't really want to soak up this thicker T88 resin or epoxy, but putting it in the press did help it. As you can see, it got mostly saturated, especially up towards this corner here. You can almost see entirely through it, and the middle is pretty well saturated as well. Just this side didn't get too much resin, it would seem. So as long as we hit in the middle, it should be an accurate representation of what a full strength of this material makeup would be. And this one is 1 pound, 2 3/4 ounces. Also including all the tape and even this excess resin that is really unnecessary, especially right here. It's a lot of resin right here and down here as well. That just didn't get picked up by the bleeder cloth. But yeah, that's just a basic overview of the plates before we go out and test them. And so I'll get to the test footage right now. They both went through. Here's that way. Alright, so this should be in frame. These are the 2 plates. This one we only hit once just because we ran out of ammo. I didn't think we'd need that much. But yeah, penetration looks like it was sort of stopping it. I think maybe it tumbled out. This is obviously the front of the first one. 3 entries. This is the back of the Kevlar. Honestly, delamination is pretty minimal. Then this is obviously the backer. Which I believe this is 4 layers of carbon fiber. Looks as though we have 3 exits, but honestly not entirely sure. So let's see if we can unfold this. Okay. Okay. Hold on. Might be getting somewhere. As you can see right here, if it will focus. That is the round. I'm gonna cover the hole real quick. I don't see an exit. Obviously, that is the round right there. And the round is in fact right here. Most of it anyways. So surprisingly, this did actually slightly work. I mean, you could say it did work, like, but I'd say it slightly worked just because, I mean, it basically fell apart. So it might not have been getting full transfer of energy. As you can see, no pass through right there. This one either. We're about like halfway through, still nothing. Here we go. Right, and about halfway through, starting to get something. So yeah, the first one stopping about halfway, and then the second one getting, I don't know, 3/4 of the way through, probably, but both of them did get stopped. As we can see here, entry, no exit, no exit, entry, and no exit. The third one, I must have missed this PE panel because it was a little bit shorter, but I'm honestly not sure what happened with the third hit. So yeah, although this got absolutely annihilated, nothing actually went through this. So it's pretty cool actually. M855 probably would have went straight through as we're barely stopping. This ball ammo. There's a couple more pieces in here. But yeah, we did stop. We did stop. 2 rounds of Full Metal Jacket with a 100% fiber composite. No metal, no ceramic, just glass, carbon, Kevlar, and PE. Which honestly, this could definitely benefit from some more glass. There's only 6 layers of a 54-ounce 3D glass weave. Not sure how big of a role the carbon played. I should probably do like an in-depth test of carbon versus Kevlar, like after a round hits ceramic. So a 100% carbon and 100% Kevlar backer, just to see which one performs better. I like slowing down a round after it's been broken apart. Not sure where that piece went, but yeah, maybe a higher quality Kevlar would perform better. I'm not really sure. We used the 14-ounce in this one, so this is everything we stopped. I wish it would focus, but it's retarded. That's the problem with the iPhone. It doesn't know when to switch cameras. Let me get closer. Now this isn't in focus. Like I should have switched to the other camera by now. So I have to do it manually. Anyways, stopped 2 rounds. 5.56 ball ammo, full metal jacket, going roughly 3,100 feet per second. So let's take a look at this plate. Obviously, as you guys can see, this Kevlar strap idea was pretty effective. Did hold these 2 panels together pretty well. As you can see, this one was in 2 pieces. This one is not. It was getting there, but it was in fact not in 2 pieces yet. Honestly, this is like a really edge shot, if I'm being honest. I don't think it would have stopped. I mean, you can clearly see where the PE ended. And I mean, it was a pretty good hit. Even if we did hit center, I guarantee you it still would have went through, but maybe we would have seen a bit better results. But yeah, this was definitely doing something, as this looks like a tumble sort of exit. Guess this stuff doesn't really stick to PE very well. Just interesting. Well, there's this. And then there's the PE panel. As you can see, Kevlar straps, barely holding on, but they were in fact holding on, barely, but good enough for it to knock them apart. So here's a 14-ounce Kevlar that we had. Honestly, not sure how much better it performed to the 5-ounce twill weave, but I mean, the round definitely didn't go through straight, I don't think. But that looks like it was at least tumbling. Here's some jacket. Carry down. Okay, my phone's gonna be retarded for the rest of the video, so hopefully you guys can see that. This one didn't perform as poorly as I thought. But nonetheless, it didn't stop it, so it didn't perform the best either. Maybe if I had just maybe a couple more layers of carbon on the back, and then maybe like 2 layers of glass up front, it probably would have stopped, honestly. This is only 10 ounces, so I doubt I'll be able to get the carbon separated from the Kevlar, but I mean, yeah, Kevlar. So probably won't be able to see underneath. But yeah, not sure how much of a role the heavier weight Kevlar played. Probably probably a significant amount, right? Because if you think about it, this plate was almost on par with this plate. This plate had 6 layers of glass up front, and this plate had 12 layers of carbon. And so the only other thing that could have been like a really major factor in slowing this bullet down was this extra weight Kevlar, unless the carbon performed better than the glass, which I doubt. Obviously, even if it had double the amount of layers, there's no way. So 14-ounce Kevlar probably played a significant role in slowing down that PE. Honestly, a higher quality PE and a more rigid backer, honestly. I'm surprised that like ripped like that, even with the 2 layers of Kevlar on the back. Okay, so I guess final thoughts. This goes over. Does it? It doesn't. Does it? It does. Not. So this plate did in fact stop 2 of the rounds. The PE kind of got pushed out of this back face mitigation layer, And so that's why I originally thought they had penetrated, but they were in fact both stopped in the PE. No exit there and no exit there, as we can see. And then we have 2 rounds worth of bullet fragments here. Finally. So yeah, there's that. 2 rounds, roughly 3,100 feet per second. And 100% fiber composite plate. We have fiberglass, carbon fiber, aramid fiber or Kevlar, and then PE, uhmwpe. And so yeah, this plate performed relatively well. It did come apart into 2 pieces, as you can see here, which we had this strap attachment system on this plate, and it didn't separate into 2 pieces. It also didn't stop the entire energy of the round, so who knows, but it was still together, so probably worth doing. I mean, it doesn't add much weight or thickness, so might as well going forward on future plates. This plate almost did stop around. We found a lot of fragments in the PE, so from that we can conclude that this 14-ounce Kevlar probably played a significant factor in slowing down the round, because this plate almost performed as well as this plate, and it had no glass up front, and this had a lighter weight Kevlar. So this heavier weight Kevlar essentially made up for the glass. And basically the glass, the 6 layers of 54-ounce 3D glass weave and the 14 layers of 5.5-ounce Kevlar essentially evened out to 12 layers of carbon and this 14-ounce, I'm assuming 3A panel. So, and this is probably lighter than the glass and the aramid. So I would assume this played a significant factor. So yeah, what can we conclude? A 100% fiber composite plate is doable. It is possible. Why we haven't really seen it from actual body armor companies, probably because one, it uses resin, and as you can see, resin is sometimes finicky, so there's a lot of variables. I assume you could probably get this down with, you know, trial and error, figure out an exact method that works and do it perfectly every time. But obviously that costs money. And for the weight, this didn't really perform all that well. This panel would roughly translate to a 4-pound plate, a full like 10 by 12 with a shooter's cut. So, and you can get a PE plate for like 3.5 pounds, maybe 3 pounds, 14 ounces. That will stop not only ball ammo, but also M855. And it's gonna probably be almost twice as thick as this, but you're getting a lot more protection, and it's even lighter. So this plate was about 0.65 inches thick. A 1-inch plate could probably, of just PE, depending on the quality, could probably stop M855. So that's probably why we haven't really seen it, you know, on the market at all. But it is doable. This plate, however, if you tweaked it a little bit, You could probably get something that would be, you know, justified in the sense of doing a 100% fiber composite plate. This was only 10 ounces. There's a bit of a chunk here, but let's just say it's a 12-ounce plate, because I mean, we do have the carbon and fiber where it's supposed to be, so the only thing we're missing is that little chunk of PE and that little chunk of aramid. So probably 2.5 ounces worth of material. So times 4, looking at, I don't know, 3 pounds, 14 ounces, which is roughly the same as, you know, the PE plate where you're getting your M855 protection, but this is only 0.55 inches thick. So you could probably get it to like a 4 1/4 plate, 4 pounds, 4 ounces, and get M855 protection while probably being thinner, probably like 0.75, so 3/4 of an inch plate. So honestly, that's pretty good in my opinion. Another thing we've learned is obviously these straps. I think I went over this already, but those are definitely worth doing just because there's literally no downside to it. It adds no weight basically and no thickness, and it keeps the plate together. So yeah, I hope you guys enjoyed this video. If you have any other takeaways that you might have noticed that I didn't cover, please write that in the comments. It'd be interesting to read about what you guys thought about these plates and how they performed, and if you guys even think that a 100% fiber composite plate is even worth doing, or, you know, researching, whatever you want to say, just the idea of it. And yeah, also if you guys have any future video ideas, also comment that down and then see if I can do those. And I'll see you guys next time.